So these are your skeletal formulas, and I told you that the nodes they won't give you these points, but the nodes on this molecule they are your carbon atoms. So basically, it's 1, 2, 3, 4, 5, 6 carbon atoms in a straight line. So that's 3. That's 6 carbon atoms in a straight line, and you can add in the hydrogens after this. Like the first one will have 3 hydrogens, right? The second one will have 2 hydrogens. The third one, 2. So it's another CH2. This is CH2, and this is CH3. So that's the molecule. If you want to do this one, it's 1, 2, 3, 4, and 5 carbon atoms in a straight line, and there's another dot that's coming out of it. So it's 5 carbon atoms in a straight line. So that's 5. And on the second one over here, there's a carbon atom that's coming out of it, either pointing upwards or downwards. So that's it. And you can add in the hydrogen. So this one will have 3 hydrogens. This one will have 3 hydrogens, 1H, and 2 H's, 2 H's, and this one will have 3 H's. Is this clear?
Yes.
Yeah.
So we can try and do this one. It's 1, 2, 3. So it's 3 carbon atoms. Remember that that's not a carbon atom, that's an OH attached to this carbon atom. And this one is not a carbon atom, that's a Cl attached. We're at this point. And the bottom one is a carbon atom. So it's 1, 2, 3, that's in a straight line. And there's 1 carbon atom that's coming out of it. The end one has an OH, and the middle one also has a Cl attached. And you can then add the hydrogens. This one will have 3 hydrogens. This one will have 3 hydrogens as well. The middle carbon atom has all its bonds completed, and this one over here will have 2 hydrogens. That's your molecule in this case. We can also try and do the ones given below, like any one of them. So this one is 1, 2. I need to draw the skeletal formula. That's 3 and 4 carbon atoms. So that's 1, 2, 3, and 4. I mean, these points are 1, 2, 3, and 4. So that's 4 carbon atoms in a line. On the second one, there's another carbon atom that's attached to it. So there's another carbon atom that's attached to the second one. And on the third one, there's a carbon atom that's attached at, I mean, the direction is not important, but there's a carbon atom that's coming out of it. And that carbon atom also has an OH attached. So you should attach an OH next to it. So again, it's 1, 2, 3, 4 carbon atoms. 1, 2, 3, 4. Second one, there's another carbon atom. So that's another one. Third one, there's another carbon atom coming out of it. So that's another one. And that third one has an OH group, and you always show functional groups. So that's this one. We can try this one. That's again 1, 2, 3, and 4 carbon atoms. So that's 1, 2, 3, and 4. Second one, there's an OH attached. And on the third one, there's another carbon atom attached, this one. So that's this molecule, right? Is this clear?
Yes, sir. Yeah. Yes.
So now quickly moving forward, we'll keep on revising this, because this is going to, I mean, we're going to practice this throughout. I mean, it's skeletal formulas would be everywhere. So the next one, we're going to start with naming organic compounds. And remember, naming is very important, because if you can't draw an organic molecule, you pretty much can't do anything after that. Like any reaction, anything, you wouldn't be able to do that. So direct questions on naming, you don't usually get very direct questions on naming, maybe just 1 or 2 marks, but a lot depends on the name of the molecule. I mean, the whole question would be depending on the name of the molecule if you don't know what the molecule is. So we're going to start with very basic naming. And so I'm going to talk about basic. Straight chain. So we're not talking about branches at the moment. So basic straight chain naming. We're going to deal with more complex naming after this one. So basic straight chain naming with double bonds. So it's going to be, the molecule would be saturated or unsaturated. So this thing, now starting with, and remember, we're just talking about simple straight chain molecules at the moment. So starting with the first thing, you should know what the counting is. This one is the first, like if you, the prefix is determined by the number of carbon atoms. So hopefully everyone knows this. It's meth, eth, prop. That's the starting name of the molecule. Bute, pent. You should remember up till 10, pent. After pent, there's going to be hex, then hept, then oct, which is for 8, and then you'll have non and dec. Non and dec. So this represents the number of carbon atoms in that straight chain. 2 carbon atoms, 3 carbon atoms. You can have 4, 5, 6 carbon atoms, 7 carbon atoms, 8 and 9 and 10. And that's your, this is our prefix, the starting name of the molecule. So hopefully everyone is aware of this, and the suffix is decided by the functional group. So we're going to start with the very basics. Alkane, and I'll briefly tell you what an alkane is. So an alkane is a saturated hydrocarbon, which means it's only going to have hydrogen and carbon atoms. And it also means that saturated means that all carbon-carbon bonds are going to be, they're going to be single bonds. So that is the meaning of a saturated hydrocarbon. It has a general formula, but remember, general formulas, in a lot of instances, they have a lot of exceptions. So they don't usually work. They only work for simple molecules. For cyclic molecules, they might not work. So there are all sorts of situations where the general formula is not going to work. But it has a general formula, which is CnH2n plus 2. Naming a simple alkane, I've got, let's say I've got 5 carbon atoms. And so this one will have 3 hydrogens. You can either draw a displayed formula or just write a condensed version. This one will have 2 hydrogens. This one will have 2 hydrogens. This has 2 hydrogens, and this one has 3 hydrogens. Asha, can anyone tell me what's the name of this molecule? What's the prefix? 5 carbon.
Pent.
Okay, so 5 carbon atoms. The prefix is going to be pent. And alkanes, the suffix, the ending part is always going to be, it's always going to be ane. So this one is pentane. Right? Is this clear? So we should move on, right? Is this clear? Alkanes.
Yes.
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 So let's move to the next one. We'll move towards alkenes now. Now alkenes are unsaturated hydrocarbons, which means they've got a double bond between the carbon atoms. So it's an unsaturated. So it's an unsaturated hydrocarbon, and unsaturated meaning that it has at least one carbon-carbon double bond. So over here, what will happen is, let's have a molecule. So things will be slightly more complicated. So I will add in the hydrogens. So the first one will have 3 hydrogens. How many hydrogens should I add with this carbon atom?
1.
Okay, so 1,
One.
because it's already making 3 bonds, 1 H with this one, 2 H's with this one. So just don't make any errors when you're adding the hydrogens. So this is the most convenient way of writing a condensed formula. Like you just keep adding the hydrogens, that's it. Condense the hydrogens only. Don't condense anything else. So So here's your molecule. So prefix, what's the prefix?
Pentane.
And
So
Pent.
Pentene.
pentene. So in this case, alkenes have a suffix of -ene. So it's going to be pentene. But the thing is, some just like alkenes, some functional groups, they would need a position, because you need to tell them exactly where the double bond is. The double bond could have been here or at any other place. So you would have to give the position of the double bond. And if it's only an alkene, we'll keep the counting very basic counting at the moment. You count from the side which gives the smaller number. So you count from side which gives smaller number to the highest precedence group, to the most important group, let's say. I mean, they use the word highest precedence, so to the highest precedence group. We will talk about precedence later on. Right now, and we'll discuss this later on, much later on. Right now, what's more important is, actually, we would have to discuss this earlier, but at the moment, let's keep things simple. You count from the side which gives the smaller number. So the double bond is going to be counted from which side, right side or left side?
left.
Left side.
So that this is first carbon atom, this is the second. So you would have to write the position before the -ene. So just before the suffix, I mean, every suffix represents a functional group. And if you want to number it or position, give it its position, then the position is written right in front of it. So this is pent 2-ene. And you count from the side which is giving the smaller number. That's one thing. I'll also add one more thing, that when you're writing names, what you should do is, I mean, there's a small rule, which is that if you have two numbers, a number and another number, there is a comma in between them. And a number and a letter have a dash between them. So it's a very small rule. I mean, you can violate, you can sort of ignore that rule even then. Yes, Puneet.
Sir, I was asking if the double bond was between carbon 1 and 2, would we have to write pent-1-ene or can we just write pentene?
So that one, usually, I mean, it's better to write pent-1-ene, but just like any formulas, the one is a lot of times just ignored. Like, for example, CH4, right? You don't call it C1H4. Do you get my point?
Yes.
Like, even if you write C1H4, there's nothing wrong with that. But the one is a lot of times it's just ignored when you're writing names and when you're writing formulas even. Right? Is the point clear?
Yes, sir. All right.
So if you just ignore one, it's fine. No one is going to be upset about it. Okay. So pent-1-ene can be written as pentene. I said now the next one, the same one, but a slightly. Sometimes what will happen is you'll have multiple double bonds. One example is, let's have a molecule. It's got a double bond. Then it's got another double bond. And add in the hydrogen. So the first one will have 2 hydrogens. This one will have 1H, 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 I think, and 2 H's. And this last one will have 3 H's. So again, it's this would be, what's the prefix? How many carbon atoms?
Hex.
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 Yeah.
Okay, so this one is hex, and it's obviously an alkene, so it's ene. But now it's got 2 double bonds, one over here and one over here. So you're going to call it a diene. I mean, if you have multiple alkenes, you write di, or if there had been 3, then you would have written tri. And you would have to give the position of each one of them. So if you have multiple functional groups, it's di or tri or tetra. So what are the positions of the two enes.
1 and 3.
So it's 1 and 3. You're going to count from the side, which gives the smaller number, which is this one. This is 1, 2, and 3. So it's one is at 1 and the other one is at 3. So is this clear? This one?
We can also say 1,3
Yes.
dihexene, right?
You can say that, but IUPAC nomenclature is hex. The 1,3 has to be written right next to the ene.
Okay. Okay. Sir.
Okay. So I mean we're following the IUPAC nomenclature, which is ene right before the suffix of the functional group. I mean, this represents the functional group, so you have to write the position right before that. If it had been all, you would have to write the position right next to it. The die just shows there are two of them. One is at 1 and the other one is at 3. So moving on, alcohols are going to be kind of the same. And when we talk about alcohols, so alcohols have the OH group. And it's only the OH group, like it should have nothing else next to it, except for the carbon chain. So alcohols, they've got the OH functional group. And also remember that the H is always on the outside. Like if I write the OH on the left side, what a lot of people do is they write it like this. I mean, I see this a lot. And they write that this is 2 hydrogens and this is 3 hydrogens, right? So when they write OH on the left side, they write it like this, and which is absolutely wrong, because it's the oxygen that's bonding to 2 atoms. So if it's on the left side, then it's going to be ON, then H. If it's on the right side, then it's OH, right? Is that point clear?
Yeah.
Yep.
Yes.
So just make sure if it's being written on the left side, make sure it's the O that's connected to the carbon chain. If it's on the right side, even then it's the O that is connected to the carbon chain, not the other way around. Now that's what an alcohol is. The suffix for an alcohol is going to be all. Now suffix is going to be all. And the molecule is going to end with all. Now, and let's try and name this molecule. Okay, let me make it simple first. Let's try and name this molecule. It's got H. So 2 carbon atoms. What will the name start with?
Two.
And it's going to end with all. And in the middle part is interesting. The middle part is AN. Now we know that it's going to end with all because it's an alcohol. You can even give the position of the OH group because it's 1, but in this case, it doesn't really matter. Who asked me that? Okay, in this case, it absolutely doesn't matter, because even if the OH was at the other end, it would still be carbon. I mean, it would still be at position number 1. So over here, it doesn't really matter. Whichever place OH is, it's always going to be 1. It's going to be, I mean, if it's on the other side, it's just a flipped version of the same molecule. So, but you can write 1 if you want to. So it's ethanol, or I mean, ethane 1-ol, which no one really writes ethane 1-ol, but it's ethanol. And the middle part, the AN part. The AN part is going to, the 2 things about the AN. If it's AN, that means it's a saturated molecule, carbon and carbon, all single bonds. If it turns out to be having a double bond, then it will change into an EN. So make sure, and this would be applied to every molecule from now on. Like any organic compound, it's going to have this middle part, which is AN or EN. That will tell you whether it's saturated, whether the carbon chain is single bonds, or whether the carbon chain has double bonds. For example, propanoic acid, pentanoic acid, pentanol, everything is going to have this AN or EN. So I'll do another example. Let's say I've got a double bond, and it's got this OH group, it's got another OH group. This one has 2 hydrogens, and this one will have 1 H, and this one will have 1 H. And this one at the end is going to have 2 H's. So let's try and name this molecule. How many carbon atoms? What's the starting prefix?
Bute.
So that is bute. And it's obviously an alcohol, so it's going to be all, right? What's the middle part, AN or EN?
Uh,
Ian.
Ian.
En.
Yeah, because there's a double bond, so the middle part would turn into N. So the EN shows there's a double bond. Now you would have to give the position of both things. Where's the double bond and where's the alcohol? You would have to give the positions of both of them, and it's a diol. The first thing, it's a diol because there are 2 OH groups, right? So that one is a diol. The EN is just 1, so that's just EN, no diene or anything. Give the position. Which side would you count this from? Right side or left side?
Right.
Why would you count it from the right side?
Because the OH is closer.
But what about the double bond? On the left side, the double bond is closer.
You can count it from any side in this case.
So now here's the counting rule now. So the counting rule is you're going to, we did write the rule. Let me just copy that rule again. And we did not discuss it. Now we're going to discuss this. So this rule. The rule is slightly, this is your counting rule. So we're gonna talk about the counting rule. So count from the side which gives smaller number to the highest precedence group. I'm just going to quickly open the. And also remember one thing. Like I'm going to show you the IUPAC nomenclature, which is a very complicated set of rules. Maybe just a second. Where's this one Wikipedia? So remember one thing. We're going to try and keep things simple. We're not going to talk about the whole IUPAC nomenclature. We're going to try and keep things simple because we just study a certain sets of. We don't study all the homologous series. We just study very few of them. And secondly, the IUPAC nomenclature is not. It's not going to work every time. It works for a certain complexity, but not for all of them. Anyway, so precedence group, this one. So here's this priority group, which is the precedence group. What that basically means is that the first one, we're just going to talk about the ones that we're going to deal with. Groups have certain importance. Some are more important, some are more special than others. It doesn't make the other ones less special. It's just that somebody arbitrarily decided that these groups are more important, the other ones are less important. So carboxylic acids, nitriles, aldehydes, ketones, alcohols, aldehyde and ketones, and amines. These are the ones that we're going to study. So I'm going to write the precedence order. So the precedence order is that carboxylic acids have the most important. They're the most important group. So you've got you start off with carboxylic acids. So you start off with carboxylic acid, and after that it was nitriles. We're going to come to nitriles later on. Then you'll have aldehydes and ketones. And after that, I think there was alcohols. And after alcohols, you had amines. So that's your precedence order. And memorize the precedence order. That these are the most important groups, the top ones. The double bond has the least importance. So even the numbering system would be provided over here. Like just a second. Like just the basic principles. So here's action number multiple, identify the side chains, identify numbering of the chain. So this one. The first rule, I mean, this is point number 6 is the numbering part, right? So I'm just going to write one point. We're not going to do the whole thing. We're just going to pick one point and that's it. We're not going to deal with a lot of complexity. So it should have the lowest number for the suffix functional group. The suffix is decided by the highest precedence group. So what this term means is, like if you go back, so if you have multiple functional groups, like if you have double bonds and alcohols and carboxylic acids, lots of things in the molecule, you number the molecule to give the smaller number to the highest precedence group. In this case, the highest precedence group is the alcohol. It's not the double bond. I mean, the double bond isn't even mentioned over there. The double bond only takes precedence if all the other things are missing. So in this case, the highest precedence group is the alcohol. It's the OH group. Is that point clear?
Yes.
Yes.
sir.
Okay, so that's this rule that, and let me highlight that rule, that you're going to count from the side that gives the smaller number to the highest precedence group. Actually, if you go back to the nomenclature, the rules of the nomenclature, you give the lowest number to the multiple bonds. That's a second priority. Like if you don't have any functional groups, then obviously you give the lowest number to the multiple bonds. Like if you have a double bond, then you give it the lowest number. But most of the time, there's going to be a functional group. So you're going to try and give the highest precedence functional group the lowest number, and you wouldn't care about all the others. Like you don't care what the other things will get numbered in what way, and counting would always be done from one side. So you find the highest precedence group, which is OH in this case, just give it the smaller number. Forget double bond, forget what number it gets. You don't care about that one. So this is carbon number 1. So this is carbon number 1. This is 2, this is 3, and this is 4. So your 2 OH groups are at positions, what positions? 1 and 2, right? And your double bond is at position number 3. Is that clear? This one.
Yeah.
Yes, sir.
And we can try and quickly do another one. Let's say, let's have a molecule. And I've got an OH here, I've got an OH here, another OH on this side. And 2 H's, I think, not 2 H's, this one will have just 1 H. So it's CH, this one will have no H, 1 H, 1 H, and 2 H's. So let's try and name this molecule. Prefix, what's the prefix? How many carbon atoms?
Pent.
That's 1, 2, 3, yep, pent. So that is pent. It's obviously an all. And AN or EN in the middle?
EN.
So
EN.
that's EN. So how many alls do you have?
3.
3.
So it would be
3.
tri.
So it's going to be triol, right? So it's going to be triol. And how many ENs do you have? How many double bonds? That's also
2.
2.
So
So
that-
diene.
so that's going to be diene. And then you write the positions right in front of them. So so which side would you count from? Left or right? I mean,
Left.
who's more important? The OH, right?
Yep.
The OH, yeah. So left.
So that's 1, 2. This is third one. This is the 4th, and this one is the 5th. So the OH groups are at 1, 2, 3, right? So one is at 1, then you have 2, then you have 3, right? And the EN is at what, 1 and 4? So it's at 1
Yeah.
and 4.
Yeah.
So that's
Yeah.
that's your molecule, right? I mean, it looks complicated, but it's not that complicated. It's you just prefix, suffix, that's decided by the functional group, middle part AN or EN, and based on the number of functional groups, based on the number of double bonds, if you have double bonds. If there is AN, you don't have to do anything because then it's saturated. You don't have to give any position for that. So AN is simple. EN, you would have to tell them how many double bonds, what are the positions of the double bonds, right? So that's how you're going to do that. Now the next one is, let's talk about the next one, which is carboxylic acids. So what happens in carboxylic acids? So carboxylic acids are the same naming structure would be followed. So carboxylic acid functional group is C. R means rest of the molecule. So, I mean, it's just a carbon chain. So it's double bond ON, OH. Like if you want to write the compressed notation, it's going to be CO and OH, COOH. Or if you want to even compress it further, it's going to be CO2H. I mean, these are the compressed versions of this one. So CO2H. Anyways, that's a carboxylic acid. The suffix in this case would change. It will be oic acid. So it's going to be oic acid. That's the suffix. The rest of the molecule would kind of be the same. So, and also remember, carboxylic acid has the highest precedence. Like in all the groups, carboxylic acid is right at the top. That means it's always going to have the lowest number next to it. So you're always going to count from the side of the carboxylic acid. So coming back to this, carboxylic acids, you got, let's say you got a double bond O and OH and two H's. Here's one H and there's two H's. So quickly tell me, what's the prefix?
Bute.
Bute.
It's going to end with what? Oic acid?
Yes.
And the middle part is AN and EN or EN. So what, AN or EN?
En.
So it's EN. And counting would be done from what side?
The right side.
So we're done from the right side. So that's 1, 2, 3, and 4. So that means the carboxylic acid is at position number 1. And the EN is at position number 3, right? So that's the name of the molecule, right? Now the thing over here is, again, you can I mean, you have a choice of not writing the 1. Usually 1 is not written. But the problem over here is that it's always going to be 1, because the carboxylic acid, based on the way it looks, like it's got a double bond in OH, so it's only got one bond left. So it will be always at the end of the chain. It will always be number 1. I mean, its position is not going to change. It can't appear at the second position. It can't appear at the third position. It's always going to be at the end. It's either going to be at this end or at the other end. Whichever end it is at, it will still be number 1. Is that clear?
Yes.
Yes. But sir, can't it be in a subgroup?
Like in what way? Like a branch?
Yeah.
We'll talk about branches later. Right now, it's just we're just dealing with simple molecules, straight chain.
All right.
And we'll leave that later. We will discuss that later. We're not going to mix this with this one.
Okay.
So it's always going to be number 1. It's always going to be at the end of the chain. Its position is not going to change. So the position over here is pointless. Like, I mean, even if you don't write it, you know it's at the end of the chain. That's it. At the end or the start doesn't really make a difference. You can flip the molecule, you can turn it the other way around. It will still be at the end of the chain. So that is carboxylic acid. And it just ends with oic. So position is kind of irrelevant for carboxylic acids. But the other groups will always be counted from the carboxylic acid side. The next one is we can do carbonyl groups, which are different, which you haven't studied earlier in O levels. So carbonyl carbonyl groups. There are actually two carbonyl groups. Carbonyl groups are aldehydes and ketones. And what is a carbonyl group? A carbonyl group is C double bond O only. Like lots of groups have C double bond O in them. A carbonyl group is C double bond O, that's it. I mean, not C double bond O and OH, not in ester, C double bond O and NO. It's got hydrogens or carbons next to it. It will just be C double bond O. That's what carbonyl stands for. And there are two carbonyl groups. One of them is aldehyde. Now, in an aldehyde, the double bond O appears at the end of the chain. So it's right at the end of the chain. And so it's going to be, I mean, one example would be like you would have double bond O right at the end of the chain. And the suffix in this case would be Al. That's the suffix. So the name of this molecule would be, it's going to be but, An, and then followed by Al. So it's going to be butanol. And you're going to count from the side that gives the smaller number. So it's going to be butan 1 Al. Is that clear? Butanol. So the
Yes, sir.
so the double bond is always going to be at the end. Now, even in this case, the one, I mean, writing the one is like redundant. You don't need that. It's because it's already understood that it's going to be at the end of the chain. And so that is kind of redundant. I mean, you just call it butanol. It's still all right. Adding the one gives you no extra information about this. The second one is ketones. Ketones are also carbonyl groups, but they're a different functional group. The suffix in a ketone is -one. So that is -one. And the C double bond O would be somewhere in the middle of the chain. So it's somewhere in the middle of the chain. Yes, Hamza.
So if it has to be somewhere in the middle of the chain, does that mean like the smallest compound won't be methanone or ethanone?
Yes.
Oh, okay.
So it's got to have carbons on both sides. So it's got to have a carbon chain on this side. It's got to have a carbon chain on the other side as well. So you can't have, at least you need 3 carbon atoms to have this. Yes, Mikhail.
So it has to be another carbon. It can't be like something else.
I mean, if it's an ace, then it's at the end of the chain. That's an aldehyde.
No, like what if there's another functional group attached to that carbon?
I told you that a carbonyl group is just C double bond O.
Oh, okay.
I mean, if it's C double bond O and Cl, let's say, then that's a different functional group. That's an acyl chloride, which you'll study in A2. So
okay.
So it has to be just C double bond O for it to be classified as a carbonyl compound. Anyways, now the position would be more. So now in this case, the position is going to be more relevant because.
Sir?
Yes.
What about the hydrogen? Like in ketones, there's no hydrogen, but in aldehydes there is. Is that correct?
But the hydrogen is like it's like something that is completing the structure. It's always there. So it's part of the carbon chain, right? I mean, carbon chain is made up of hydrogens and carbon. Is that clear?
All right, I see. Yes.
So we'll just do this last one. Ketone, the position becomes more relevant. So because you have to tell where in the middle exactly. So in this case, And why don't we put a double bond as well? Sorry. So let's put a double bond here. So this one would be pent, right? And
Yes.
it's going to end with on,
Yeah.
and there's going to be en as well. So which side will you count from?
Doesn't matter.
The right.
It's going to be from the right in this case because at the end of the day, the goal is to have the smallest number, right? For the ketone, it doesn't really matter which side you count because it's still going to be 3, right? But
Yeah.
but the numbering goal is that overall that's going to be it should have the smallest number. Like over here, the ketone, it's completely irrelevant which side you count from. You're always going to get 3. So you're gonna look at the double bond. You want to give that the smaller number as well. Then, if you have a choice, which in this case we do have. So it's going to be pent. The double bond is at 1, and the ketone is at position number. It's at position number 3, right? So it's pent 1 en 3 on. Okay. So is this clear?
Yes.
Yes.
So
Yes.
just remember, aldehydes and carboxylic acids. I mean, in that case, they don't. That's where it doesn't really matter because they're always going to be at the end of the chain. Even in that case, if you write the numbers, the numbers just don't give you any extra information, but it doesn't make the name wrong. It's still correct. For ketones and for double bonds and for alcohols, the numbering is more important. Okay. So let's continue next time then. Okay. Is this all clear?
Yes.
Yes.
All right,
Yes.
sir. Allah Hafiz.
Okay.
Yes, sir. Okay. Hafiz.
Perfect.
Thank you.